So with this, we will start our next video for the playlist, data science playlist. And our topic for this video is dimension reduction. What is dimension reduction basically? Dimension reduction techniques are used to simplify data sets with many variables while retaining as much relevant information as possible. It helps improve model performance, interpretability, and computational efficiency. This guide describes identifying multicollinearity and applying principal component analysis using Python and R in a descriptive manner. What is identifying multicollinearity? Now, you might be thinking, what is multicollinearity? So, let me explain. Multicollinearity occurs when two or more independent variables in a data set are highly correlated. This can distort regression model coefficients and reduce model interpretability. Methods to identify multicollinearity are correlation metrics. It computes pairwise correlations between features. And second is variance inflation factor, that is VIF, quantifies the extent of multicollinearity for each feature. Higher VIF indicates high multicollinearity. The implementation of dimension reduction can be done in Python for multiple purpose. One of it is using correlation metrics. We can use correlation metrics by using the keyword CORR and a parenthesis. And using this syntax, we can easily check whether the two matrices correlate with each other or two data sets correlate with each other with how much factor. Now, using variance inflation factor, that is VIF, that can also be done by we can check by this we can check how much is the variance among different factors. Now we can also implement it, this in R by implementing correlation metrics. In R, we can implement correlation metrics by using a keyword known as COR along with the data set in which you want to use the correlation metrics. Second is using VIF. One can use VIF by using the VIF model along with using the keyword LM. Now, what is second topic that we will cover in this video is principal component analysis. What is principal component analysis? The abbreviation for it is PCA. PCA is a dimension reduction technique that transforms a high dimensional data set into a lower dimensional space while retaining the maximum variance. It creates new variables called principal components, which are linear combination of the original variables. Now, implementation in Python. It can be implemented in Python using various steps. The steps involve importing libraries, second, standardizing the data, third, applying PCA, then visualize PCA components, and by this we can implement it in Python. We can also implement PCA in R using various steps. The steps involve loading libraries into a main program, then standardizing the data for checking all the remaining data. Third, apply PCA, then visualize PCA results, and at last, with this, we can implement PCA in both Python and R. Now, Comparison of outputs. Comparison of outputs can also be done. In multicollinearity, correlation metrics can be used for comparing of outputs. Visualize pairwise relationships. VIF quantifies collinearity for each feature. And in PCA, explained variance determines the importance of each principal component and transformed data set that reduces dimensions while retaining variance. Conclusion: identifying multicollinearity helps improve regression models by removing redundant features. Principal components analysis reduces dimensionality, making models computationally efficient while preserving essential information. Both tasks can be seamlessly implemented in Python and R, depending on project needs and expertise. With this, we end our video. Thank you.